All right, let's do another example with factoring a polynomial. And we want to factor this fourth degree polynomial, x to the fourth minus 9x cubed plus 27x squared minus 15x minus 52. And we're given some information about it. We're given that 3 minus 2i is a 0. Now from the conjugate zeros theorem, we know that since this polynomial has real coefficients, 1, negative 9, 27, negative 15, and negative 52, that if we have a complex number 0, its conjugate must also be a 0. So we know immediately that 3 plus 2i is a factor. So we'll have x minus 3 minus 2i. That will be a factor. Also, x minus 3 plus 2i, the conjugate, will also be a factor. All right, so if both of these are a factor, then the product will be a factor. So let's multiply this out, and then what we'll do is we'll take that and divide it into our polynomial and see what's left. Okay, so we have x times x, that's going to be x squared. And then we have minus x times 3 plus 2i minus x times 3 minus 2i. And then we have plus 3 minus 2i times 3 plus 2i. All right, I'll get out of the way here. So we're just foiling this out, leaving the complex numbers as one thing. Okay, now let's distribute all of this multiplication here. Distribute the x's and then multiply out these conjugates. So we have the x squared. We'll distribute here. Negative 3x minus 2xi minus 3x plus 2xi. That's good. And then these are conjugates, so we're going to have 9, outside inside cancel, minus 4i squared. Okay, these terms with i's cancel. Minus 3x becomes 6x. So we have x squared minus 6x. Then we have plus 9, and then this is going to become minus negative 4 with the I squared. So we have 13. All right. So this is a factor of our original polynomial function. And so if we divide this out of our function, we should, get a remainder of 0, and then the quotient will be the other factor. So let's do that. Let's set up our long division. So x squared minus 6x plus 13. We're going to divide that into our polynomial, x to the fourth minus 9x cubed plus 27x squared minus 15x minus 52. All right, so we're looking for a number such that if we multiply x squared, we get x to the fourth. Number is x squared. So x squared, x to the fourth, minus 6x cubed plus 13x squared. And then we subtract. So we're going to have a minus here, so it's gone. Plus 6x, so it's minus 3x cubed. We take 13 away from 27, and we get 14. Bring down the negative 15x. And now we need to multiply x squared by something to get negative 3x cubed. That is negative 3x. All right, So negative 3x times x squared is negative 3x cubed plus 18x squared, and then I will have minus 39x. And then we subtract. So this is going to go away. We'll take away 18 from 14 and get negative 4x squared, and then we'll take away, we'll add positive 39 to 15 and get 24. 4x. Bring down the minus 52. And now we need to multiply x squared by something to get negative 4x squared. Negative 4. Negative 4x squared. Looks like plus 24x. Negative 4 times 13 is minus 12 and 52. And then we subtract. These happen to be the same thing, so if we subtract them, we're going to get 0. All right, so we've verified that this is indeed a factor of our polynomial, and we now have a product that is this polynomial. So we have that f of x is going to be this, which comes from the two conjugate zeros, and then we have our quotient. So x squared minus 3x minus 4. All right. Now to finish the problem, we want to factor it completely. So we'll take this and break it back down into its complex factors, and then we will factor this, which I believe is going to factor without any other technique. So let's use a bracket here. X minus 3 minus 2i. We'll have x minus 3 plus 2i. And now we will factor this. Looks like we have x minus 4 and x plus 1. All right, so we've taken our 4th degree polynomial and we have factored it, and here we have our 4 factors.